Today, we are going to start with the next part of the chapter, P block elements. Today we will talk about group 16 elements, which are also known as chalcogens. Chalcogens means ore forming. Most of our ores are either the oxides or sulfides. That's why the name. Group 16 contains oxygen, sulfur, selenium, tellurium and polonium. The general electronic configuration is Ns2, Np4. Let us talk about occurrence first. Oxygen is the most abundant of all the elements on Earth. It forms about 46.6% by mass of Earth's crust. Dry air contains approximately 21% oxygen by volume, whereas sulfur is present only 0.032 to 0.1% in Earth's crust. Sulfur also exists as sulfates, for example, calcium sulfate, magnesium sulfate, barium sulfate, and as sulfides such as lead sulfide, zinc sulfide, and copper pyrites. Traces of sulfur also present in the form of H2S in volcanoes. Some organic materials such as eggs, proteins, garlic, onion, etc., they also contain sulfur. Selenium and tellurium are found as metal selenides and tellurides. Polonium occurs in nature as a decay product of thorium and uranium. Now some of the properties. First is atomic and ionic radii. Due to the increase in number of shells, atomic and ionic radii increases down the group. Size of oxygen is, however, exceptionally small. Ionization enthalpy decreases down the group. It is due to increase in the size. However, the elements of this group have lower ionization enthalpy as compared to those of group 15 elements. Electronegativity. Next to fluorine, oxygen has the highest electronegativity value among all the elements. Within the group, electronegativity decreases down the group. Electron gain enthalpy. Because of the compact nature of oxygen, it has less negative electron gain enthalpy than sulfur. However, from sulfur onwards, the value goes on becoming less and less negative. Melting and boiling point increases down the group because of the increase in size. Metallic character also goes on increasing because of decrease in ionization enthalpy. Oxidation states. The most common oxidation state of group 16 elements is -2. Stability of -2 oxidation state decreases down the group. -2 oxidation state arises because it has a capability to gain 2 electrons. Oxygen shows only -2 oxidation state except in case of OF2, where its oxidation state is +2 because fluorine is more electronegative as compared to oxygen. Other elements of this group also show +2, +4 and +6 oxidation states as they are capable of forming covalent bonds. But Plus 4 and plus 6 are more common. Sulfur, selenium and tellurium usually show plus 4 oxidation states in their compounds with oxygen and plus 6 with fluorine. Stability of plus 6 oxidation state decreases down the group and the stability of plus 4 oxidation state increases because of inert pair effect. The most common oxidation state for chalcogens are, it means -2, +2, +4 and +6. Again, oxygen being the first element of the group has some of its properties which are different from the rest of the elements. Means it shows anomalous behavior. Like oxygen is a gas while all others are solids. Oxygen is diatomic, others are polyatomic. Oxygen is paramagnetic, whereas others are diamagnetic. Oxygen forms hydrogen bonds in hydrides, alcohols, and carboxylic acids. Oxygen can form p-pi, multiple bond. Oxidation state of oxygen is -2, where it is only +2 with fluorine. However, others can also show +2, +4 and +6. Oxygen mainly forms ionic compounds. Reactivity with hydrogen. All the elements of this group form hydrides of type H2E. Their acidic character increases from top to bottom. This is because the bond dissociation enthalpy decreases down the group. Due to the decrease in bond dissociation enthalpy, thermal stability also decreases down the group. And that's why reducing character increases down the group. Reactivity with oxygen. All elements of this group form oxides of type EO2 and EO3. Sulfur dioxide and O3 ozone are gases, whereas selenium dioxide is solid. Their reducing properties decreases down the group, that is from SO2 to tellurium oxide. Both dioxide and trioxides are acidic in nature. Reactivity towards halogens. Elements of this group form large number of halides of type EX6, EX4 and EX2. Stability of these halides decreases in the order fluorides are more stable, then chloride, then bromide and iodides are least stable. Among hexahalides, hexafluorides are the only stable halides. SF6 is exceptionally stable because 6 fluorine atoms surround the sulfur. All elements except oxygen also form dichlorides and dibromides. These dihalides are formed by sp3 hybridization and have tetrahedral structure. Dimeric halides may undergo disproportionation, like Sc2Cl2 disproportionates to form SeCl4 and selenium. Among tetrafluorides, SF4 is a gas, SEF4 is a liquid, and TEF4 is a solid. Tetrafluorides have sp3 hybridization and trigonal bipyramidal structure. You can see the structure of different types of halides. SF6, it has octahedral geometry where central atom undergoes sp3 D2 hybridization. SF4 you can see here, it has a seesaw type of structure. Geometry is trigonal bipyramidal where equatorial position, one of the equatorial position is occupied by lone pairs of electrons. In case of SCl2, the structure is inverted V, where sulfur is surrounded by two lone pairs and two bond pairs of electrons. So geometry is tetrahedral. You can also see one more halide, S2F2. Here also you can see pyramidal shape with lone pair of electrons on sulfur. Thank you.